Hi guys, in this video I'm hoping to simply demonstrate the use of bilinear interpolation to extract an exact value from a given data using Excel. We will be using match and index function to demonstrate this here. You know, whether you're an engineer, an architect, a builder, an estimator, or any kind of profession which really involves dealing with numbers, then you would most likely be dealing with tables with very similar format like the one we have here. Bilinear interpolation, or what others may call it, multiple interpolation, is simply interpolating the values given by the user in the row as well as the column simultaneously to work out the exact number within the body of this table. In this example, I have shown here the value of CPT roof, which is the roof pressure coefficient, is what we want to work out. This method in general could be very useful to save so much time in the office, especially if you're working with complicated formulas in repetitive designs that requires to extract values from specific tables, and these tables could be from a particular Australian standards, user manual, or design handbook, and so forth. So let us get into it. I have chosen this table from the Australian standard wind loads for housing, AS 4055. I think it's on page 60 from memory. So from this table we have a relationship between the roof pitch in degrees and the building height to width ratio, H over W. So from these two values, which the user will need to put in, we can then work out the roof pressure coefficient, CPT. The formula actually used for bilinear interpolation is a very large formula, as you can see here. So we need to work out all of these x and y parameters in the formula to arrive at the exact value of the roof pressure coefficient. What are these x and y parameters that we have here? I'll go through them. Y is the user input, H over W, and x is the user input of roof pitch in degrees. Y1 and x1, they are the lower bound values, and y2 and x2 are the upper bound values. I'll explain that a little further in the video. F of x, y, they are the values of the pressure coefficient at a given position of x and y within the table. Okay, so for example, let us first actually number the cell position of the table. So here we can number the rows, okay, as 1, 2, and 3. And this would be my y values, okay, which is the H over W. These are all going to be my y values. Then we can also number the columns as 1, 2, 3, 4, 5, 6, and 7. And this would be my x values, which are the roof pitch in degrees. So for example, say we have f of 5 and 1. So f of x and y is f, 5, and 1, which means x is equal to 5 x is at position 5 and y is at position 1. Then my CPT is clearly 0.9. Okay, or maybe if, let's say we have f of 3 and 2, which means x cell is at position 3 and y cell is at position 2. So then my CPT is 0.2, and so forth. So keep this idea in mind because we need to tabulate it all later in this video. Okay, step 1. Let us go first to the diagram tab here and fill in all the user information. Alright, as you can see, here we have, we're ultimately trying to calculate the pressure P, or the pressure P on the surface of this double-story building. The formula, see that big formula, has CPT roof in it, and it also has CPT wall, which is the wall pressure coefficient as well, but for the sake of this exercise we will only extract the roof pressure coefficient from the table. Okay, and maybe later you can try to do the same with the wall pressure coefficient as well if you want to. Okay, so here we're given HL, which is the lower roof height, or the lower floor height, that 2740, 2,740 millimeters. Okay, HF is the floor height, and that is 320 millimeters. Generally the floor trusses are about 300 millimeters, and then you add 20 millimeter flooring to it, so it's all added up to 320 millimeters. Then we also have HU, which is the upper floor height, which is 2590. The total height H is then, we come over here and say equal, sum, open a bracket, and then E33 colon to E35, and then close the bracket, which gives the total height of 5650 millimeters, and that is from the ground level or the floor level to the eave line. Okay. Then we have the roof pitch, which is 22.5 degrees, and finally the width of the building parallel to the wind pressure or wind direction is 12,000 millimeters. That's the width of the building. Okay, second step, we go back to the table tab. As you can see here, we have set this up so that the user input from the diagram tab could automatically appear in this sheet here. If you noticed, we've converted all the units to meters. So for the total height, we just divided 5650 by 1000 and 12,000 millimeters by 1000, which get it all in meters. Then we've set a table with all these x and y parameters, which we have spoken about before, to work out that big bilinear equation. Let's begin to fill it in and take this step by step. I know it is a bit tedious, but once we get it all set up, it makes life so much easier for yourself and all the other guys in the office as well. So firstly, the value for y, which is simply h over w, and that would be the total height, 5.65 meters, divided by 12 meters, and that is equal to 0.47. Then we have the value of x, which is the other user input of 22.5 degrees for the roof pitch, so equal 22.5 degrees. Okay, now we take 0.47 and 22.5 degrees to the table, and you will notice that there is no numbers exactly matching these two values in the rows or the column, so we don't have an exact match. So then we have to interpolate between the row as well as the columns. So let's now work out the lower bound value y1. So for the value of y, we have 0.47. Then from the table, 0.47 is greater than 0.25 and less than 0.5. Therefore, the lower bound value in this case of y1 should be 0.25. To extract this out from the table, we first need to use the match function. Okay? The match function determines the position of the cell that we want to extract. Right. Once we get that, then we can use the index function to determine the value of that cell. It can be a bit confusing, but we'll give it a shot here. So we're expecting that the cell position of 0.25, which is a lower bound value, to be within the first row, which is y is equal to 1. So let us see how this works out. So we come over here and type equal, match, open a bracket, then select the cell that we want to match, which is 0.47, then comma, then select the entire row from 0.25 right to 1. So we're matching it with the row, okay? Then comma, then type 1, and then close the bracket. Now, this one here at the end is basically telling Excel to give us the lower cell value, which is just lower than 0.47. So here we have the value of 1, which just means that the lower bound value of y1 in a cell reference number is 1. Okay. Now we want to find out the value of that cell. Okay, so the reference cell is 1, we want to find the value of that cell. So we come over here and type equal, index, open a bracket, then type the entire row, again, 0.25, colon, right to 1, then comma, then click the cell value that we found before, which is 1, then close the bracket. So here we go, we got 0.25. Okay, so the cell value is 0.25 at reference 1. Now we can work out the lower bound x1, the lower bound value of x1, exactly the same way. So we come over here, type equal, match, open a bracket, 22, what are we matching? 22.5 degrees, then comma, then we select the entire relevant columns, which is from 0 degrees right to 35 degrees. Then comma, and type 1 again to give us the lower value, then close the bracket. So here we get the lower bound x1 cell value, which is 4. We can double check that. So if we go back to the table, we can clearly see that the lower bound x1 should be 20 degrees, which is just lower than 22.5 degrees. And the cell reference here is 4. So we're on the right track, I guess. Then we do the same as before. We find the value of x1. We come over here, type equal, index, open a bracket, then select the relevant columns from 0 degrees right to 35 degrees, then type comma, and click on the reference 4 that we found before and close the bracket. So yeah, so as expected, we got a value of 20 degrees. So let us move up now to the upper bound values, y2 and x2. For y2, this is an easier method. For y2, we know that the lower bound cell value of y1 is equal to 1. Right, actually we know that, yeah, the actual cell value is 1, but the value of 0.25, okay, that's a lower value. Then automatically we can say that the upper bound cell value of y2 is just simply 1 plus 1, which is equal to 2. So we don't have to rewrite the match function again. All we need to do is just simply come over here and type equal, then click on 1 that we found before and just add another one, and then close the bracket. So yeah, so here we go. The upper bound y2 cell, the reference of y2 is at 2. The cell number is 2. Then to find the value of this cell reference, do the same thing. Equal, index, open the bracket, select all the rows again from 0.25 to 1, comma, and then select reference 2 this time and close the bracket. So as we expected, the upper bound value of y2 is 0.5, which is the next number greater than 0.47. Okay, then the same thing when we're finding the upper bound cell value of x2. We know that the lower bound cell value of x1 is equal to 4. Do you remember that? Where we had 20 degrees, which is at 20 degrees. Then automatically we can say that the upper bound value of the cell of x2 is just simply 4 equal 4 plus 1, and that will give you 5. Yeah, so that saves us time, so we don't have to rewrite the match function again. So yeah, to get the value of the cell of 5, we did the same thing with the index. So we come over here and we write equal index, open the bracket, and select the relevant columns from 0 degrees to 35 degrees, and comma, then select on the reference cell 5, which we got before, and close the bracket. Wow, so here, that's 25 degrees. It is a long process, but yeah, we're coming towards the end. Now we need to come to the last part to work out f of x1, y1, f of x1, y2, f of x2, y1, and finally f of x2 and y2. So this is that tricky part here. So if we look here at the table, we would know that the exact value of CPT would have to be between these 4 highlighted values. I'll highlight them. So there will be between 0.8, 0.6, 0.9 and 0.8. So how do we extract these values from the table? Well, all we need to do is use the index and match function this time in one hit. Okay, so for f of x1 and y1, we click here, type equal, index, open a bracket, and now this time we need to select the entire pressure coefficient values of CPT in the table, and not just the row alone or the column alone. We're going to select the entire values. So select from 0 right to 0.8 here, then comma, and then the reference cell this time should be x1 and y1, where x1 is 4 and y1 is 1 respectively. Okay, but when we write this in the index function in Excel, we always have to remember to write the row first, then the column, and that's the tricky part. Okay, the row first, then the column. So here we have to say 1, okay, and that's the row, then comma 4, which is the column, and close the bracket. So yeah, so here we go, we got the value of 0.8. So let's double check that to make sure we did the right thing. If we go back to the table and search x1 reference cell 4 and y1 reference cell 1, we have a value of 0.8. So we are on the right track. Now we have to do the rest of the values exactly the same way. Okay, so for f of x1, y2, what we can just do is copy the formula, copy and paste the formula, because the tables are exactly the same, the reference tables are exactly the same. The only thing that changes are the references of the cells. Okay, so we copy and paste the formulas, and here we already have the index and the entire values of the CPT in the table, and then a comma, and then the reference cell here will just be 2 for y2, comma, and 4 for x1, and close the bracket. For f of x2 and y1, again, same thing, copy and paste the formula, equal index, and we have the entire CPT values, comma, and then the reference cell here would be 1 for y1, comma, 5 for x2, and close the bracket. And finally, f of x2 and y2, copy and paste the formula, equal index, and make sure that the CPT values are in there, comma, and then the reference here would then be cell 2 for y2, comma, 5 for x2, and then close the bracket. And now we finally have all the values required to use the bilinear equation. So all we need to do is just take these values and plug it in all in that big equation to work out the exact value of the pressure coefficient. I just did my full calculations in the tab, in the calc tab. So if you come over here, actually broke the equation down into several parts to make it easier for myself, make it easier to follow. So please bear in mind that there are other methods that we could use to achieve this bilinear interpolation, such as the forecast function, which we can cover in a different video. But I thought to demonstrate this traditional method for us to learn how to use the match and index function. So yeah, I hope this video is useful for you, and hey, if you have any questions, please do not hesitate to write it in the comments below, and I'm more than happy to answer any questions you have. Best of luck with it, and thank you for watching. Thank you for watching again.